Welcome to aminacademy.com in Analytical Solid Geometry regarding equation of sphere with which cuts another four spheres orthogonally. We have to find a equation of a sphere which cuts another four spheres orthogonally. We'll find the general condition for this. Let the given sphere is equal x square y square z square plus 2ux 2vy plus 2wz plus d equal to 0. It's a general form of the equation of the sphere. Now, another four spheres which cuts the above sphere orthogonally each, then we can write that is x square plus y square plus z square plus 2u I x 2v I y plus 2w I z plus di equal to 0, where I is a suffix, that is I is the value having 1, 2, 3, 4. Means if you put the value of I here 1, 2, 3, 4, then we'll get four different spheres. Now we'll start the problem. The condition that two spheres orthogonally, here we are having four spheres, then we can say the condition that is two ui plus 2 vi plus 2 wi equal d plus di, where I equal to 1, 2, 3, 4, which means here this original sphere is here, each sphere cut orthogonally with the original sphere. We can use the value here 1, 2, 3, 4. Like here, first sphere is orthogonally cut with the given sphere is 2u u1 2v v1 2v w1 equal d plus d1. Like you had to use 2, 3, 4. Now the conditions, we'll write these conditions each and every spheres, that is v, that is minus d1 plus 2u u1 plus 2v v1 plus 2w w1 minus d equal to 0. This is a 1. That means we are substituting I is 1. The condition for the two spheres cuts orthogonally. Like for second sphere, that is minus d2, here this come here, this minus d2 2u u2 2v v2 plus 2w w2 minus d equal 0, equation 2. Like third, minus d3 plus 2u u3 plus 2v v3 plus 2w w3 minus d equal to 0. Like fourth one, minus d 4 plus 2u u4 plus 2v v4 plus 2w w4 minus d equal to 0, equation 4. Here with these four equations, we can find the general condition for these four spheres is orthogonally cut with the original sphere given. That means we have to eliminate u, v, w, u, v, w, and d from above equations 1, 2, 3, and 4. We get in determinant form. For simplicity, we'll write the determinant form. That is x square plus y square plus z square, x, y, z, 1. Then second, minus d1, u1, u2, u3, minus 1. Then minus d2, u2, v2, v1, v2, v1, w1. Then u2, v2, w2, minus 1. Then third, d3, u3, v3, w3, minus 1. Next, d4, u4, v4, w4, minus 1, which is equal to 0. That means if you calculate the determinant value of this 5 into 5 order, we can get the condition for that given four spheres is orthogonally cut with a given sphere. Now let us do an example regarding this concept. Look at this. Here, find the equation of the sphere which cuts orthogonally of the four spheres. These four spheres are given S1, S2, S3, S4. We have to find the general equation. Now, the required equation, let required equation of sphere, general form is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. Let it be 1. Now, if this sphere cut orthogonally with the first sphere, then we can use the condition. Now the condition first. Condition for orthogonality is 2u1, 2v1 plus 2w1 equal d plus d1. Using this condition for this sphere and sphere S1, we will have here u equal a, u equal to, therefore we have the condition after simplifying or putting this first condition is 2u, u1 is here a, other things are zeros like 2 u a equal d minus a square, because here this is here a square here, because d plus d1, d1 is here minus a square. Similarly, we can find for the second sphere we have 2 2UA 2VB equal D minus B square with third 2WC equal D minus C square. And last sphere is S4 equal to x squared plus y squared plus z square equal to a squared plus b squared c square. Here ABC is 0 and therefore here D equal a square plus b square plus c square. Now from all, that is 2, 3, 4, 5, that equation will get here. First we'll get 2u a equal d minus a square and d are having a square plus b square. Here from 2 we are having 2ua equal d is a square plus b square plus c square, that is from 5, and minus a square. Cut both. Therefore here we are having 2u equal b squared plus c squared over a. Similarly 2vb equal d minus b square. D is, you have to substitute a square plus b square c square. We are getting 2v equal c square plus a square over b, and 2w equal a square minus b square over c. So we are having the values 2u, 2v, 2w, then substitute in equation 1 from 1. Therefore we are having equation x square plus y square plus z square. Here we are having 2u, 2v, 2w, we have to substitute in that. So we are having then b square plus c square b squared plus c square over a. So we'll write one more time here, x square plus y square plus z square equal b square plus c square over a x plus c square plus a square over b y, then plus a square plus b square over c z plus a square b square plus c square equal 0 is the required equation of the sphere. We have done. please subscribe our YouTube channel.